All right, we're going to get started. And Linda's going to show up in a little bit. So I apologize about that, folks. She just didn't know exactly where the place was, and I probably should have checked earlier that she's managing. Okay, thank you everybody for coming. I know it's Thursday and it's not always the most ideal day for a meetup, but we wanted to take advantage of the fact that Linda's in town, post summit, continue the celebrations just a little bit. So, hang on. I realize I'm not actually connected to this. Give me 1 second. You know what? Let me just do that. Because nobody needs to see me, really. לא שומעים? לא, בסטרים לא שומעים? No, this is we can only unmute one. Let me know if we have sound on the stream. Now let's play this. Let's play this guy and then we'll see. We do have sound on the stream. Okay, we're good. Eric, are you sure? Because I can hear the sound, so I just want to make sure that we do have the sound on the stream. No, maximum. For these opening slides, it's not critical. So welcome to Serverless Nights TLV. It's been quite a while since we had our last meetup. Serverless Nights TLV is now part of the TLV community, so you can find all the information about our community at tlvcommunity.dev, also on Twitter at TLV Community. My co-organizer is here. Say hi to David Melamed from JIT, CTO and co-founder. But we also have Eric Zadi, who's a co-organizer of DevOps Days and Cloud Native IL and StatsCraft IL, and all of these excellent conferences that are all part of the TLV community that you're welcome to follow and discover all of our events. We do events obviously on DevOps and Cloud Native and open source and monitoring and observability and serverless and all these wonderful things. So join our community and get involved. It's really fun. We're all awesome, as you can see. Just a heads up, while the last time we had a meetup, this was actually an open call for papers. The call for papers has officially closed. Hang on, let me take the ticker off now that we've gotten started. Sorry about that. That's kind of annoying to have on the screen. Okay. And we're back. But just stay tuned because now that the CFP has closed, we are going to be announcing the agenda soon, and it's going to be super awesome because we got a bunch of really good talks. So stay tuned for DevOps Days Tel Aviv and registration and when it opens, and join us because it's one of the best events in Tel Aviv, and I am not biased. So that's coming soon. And we'll have some great serverless talks there as well, because there's the cloud native track and other stuff. So there's going to be a bunch of cool stuff happening. If you want to stay involved, oh, this is kind of blocking this one, so I guess you can only join. Oh, you can't join that either. Never mind. Let me fix that so you guys can join our community. There we go. We have a Telegram and we have a WhatsApp, and you can still only join the Telegram apparently because I have this overlay. Oh well. But I can share that later. But yes, we have a community Telegram, we have a community WhatsApp, and there are the places that I constantly blitz and annoy people and tell them when we have meetups and other things happening. You can join those if you want to get that information. We do run a lot of events all the time, and you are welcome to join us. We would really be happy to have you and learn about the ways that you can also contribute talks like CFPs that open and things like that. We always want our community members to take a meaningful impact and be a part of our community. Which on that note, I want to thank our speakers who stepped up very, very last minute, Avishag, Sahar, and Jonathan Rosenboim from Avishag, Sahar from LinearB, who are hosting, and Jonathan Rosenboim from JIT, who are going to be doing 2 excellent talks, in addition to Linda Haviv, who's going to get here any minute. I assure you, she's on her way. One last thing, Yishai Be'eri, CTO of LinearB, and I run a very awesome podcast called Dev Interrupted, in Hebrew, Pituach Ba'afra'a. This is the QR code which you can scan. I assure you it's a really good podcast, and not just because I produce it. I'm going to let Yishai come on up and tell you a few words about LinearB, who are hosting us and are super awesome. So take it away, Yishai.
Toda Sharon, thank you. Hey everyone, great to have you here at LinearB's Tel Aviv office. I'll tell you like 3 sentences about LinearB. We are a startup that provide a platform to help developers and developer organizations move faster, be more productive, have a better dev experience. Welcome to look us up and start improving your dev process. We have about 100 people overall, about 50 here, 50 in the States, and really thrilled to have you all here. What's the next speaker? Who's up next? Avishag is the first. David Melamed.
Yeah, thank you. And first of all, thank you for LinearB for hosting this great meetup. I'm super excited to be here. Yeah. Applause for LinearB. Super excited. I've been in the serverless world for a couple of years already. Been there from the first version of Lambda. I don't know who can say that. Who was there a couple of years ago when there was no monitoring, no ecosystem. So I think that we've come a long way since. And one of my dreams back then when I was working in CloudLock was to create at some point a product and a platform that's completely built on serverless, 100% serverless. And this is what we did. This is what we built at JIT. I'm the co-founder and CTO. And so it was very important for me to start from day one serverless. We built that. JIT.io is a DevSecOps orchestration platform. Basically, we want to take care of your whole product security, of your whole SDLC, from the code to the pipeline to the runtime. We'll deal with everything. If you're interested, you can come to me. And if you have any question about serverless, how to build something at scale from 0 to high scale, you can also come to me afterwards. Thank you very much.
Amazing. All right. So without further ado, we are going to get started with our excellent talks, starting with Avishag. Oh, wait, I want to do this the other way around. I'm going to make you a tiny bit smaller, Avishag. You're going to be a little bit small.
This is my dream, to get smaller. It's a joke.
Amazing. So
it's a joke. Okay, I'm going to start. So hi, everyone. I'm Avishag, and today I'm going to give you my point of view. I actually have sort of a clicker. 1 second. Okay. No. Welcome. We just started, so you didn't miss anything. Okay, so I'm going to give you my point of view of serverless, my experience and the milestones till I got the first time that I actually used it. I want to understand, like, any of you use serverless these days? Yes. Oh, not all of the hands. Okay. Anyone consider to shift to serverless? Okay, thank you. Okay, so we'll start with it. Okay, I'm going to start by introducing myself. I'm Avishag. I live in Ramat Gan. I started my tech career in the military. In the Unit 8200, I was working there as a PI developer. After 2.5 years, I moved to Allscripts. My first job in the Israeli industry was there. I was developing healthcare systems, specifically healthcare systems that specialize in the analytics part. And after almost 4 years, I moved to Cisco. In Cisco, I first started developing in the AWS framework. It was my first time experiencing how to work like with cloud computing. And about two years and 2 days, actually, I joined LinearB. I started here as a software developer, and now I work as a team leader, a hands-on team leader. So I also code. And this is basically the background. I want to take you to a journey with me of my career and how I started and when I first met serverless and what it meant for me. So long time ago, I was working for the military and all scripts, big corporates, huge corporates, I'd say, and I was developing there on-prem. Most of you probably understand what it means. It means basically that we managed our own service, our own hardware. So basically, this was my main job for a while. And if I'm thinking about it, and I want to use this car analogy, it's kind of as if I am owning my own car, okay? So let's think about service and resources as cars. So basically, this is what I want you to think. And how would how the organizations that I was working for looked like. So I could separate the R&D group into two groups, two groups, okay? So we have the devs, and we have another department. So the devs, the developers, were mainly focused on developing features. Were mainly focused of developing algorithms. They were focused on the product features and so on. And we had another group that was responsible of all of the maintenance, right? So we had group of system administrators and DevOps and IT and a lot of people, a lot of personas that worked there, and we coexisted together. It was fun. And if we wanted to scale up, what we had to do, we had to either recruit more people to join our groups, and in terms of the hardware, we had to get more hardware, right? So if we want to scale up and we want to support more or deliver more, this is what we had to do. Or sometimes we had to do this upgrade. This is something that I remember from the army when we had to upgrade one of the databases into a super database that was extremely faster, and it was something else. So these kind of things were very typical to organizations that work on on-prem strategy. So if I'm looking on a day-to-day, I was more focused, as I said, on features, less of maintenance and ops, and minor context switch within my team. While the IT/ops/sys administrators were more on the maintenance and ops, less about the features, and also had minor context switch within their group. But one time, I remember that, not one time, actually a lot of times, when we had to do when we had to work on something that involved both of the teams, let's say a huge migration to another database, we had to collaborate. And then the context switch started to cost us more. And then our management called this from a minor task, it's going to be a huge project, and you understand what it costs for us. A lot of money. So this whole thing about on-prem cost a lot, not only in terms of the hardware that we are paying, not in terms of the talent, but also it takes a lot of time to do that. So this is one of the main disadvantages that comes with an on-prem. Sometimes it's not something we can control of, right? Because I think about like where I was working on. I was working in the military and all scripts. I was working with sensitive data and also super high confidential data of clients because it's healthcare. So sometimes we don't have a choice, but it is what it is, and it's not that cheap. It's very typical for big corporates to support that kind of thing because they can do it. They have the money, they have the ability, so this is what they choose. But it's not optimal for every company. And this is like this is the background. Moving forward, I joined Cisco. This is where I first met the cloud computing. So specifically, I was working in AWS. I met the cloud, And the cloud is very, very fun. Why is that? It's because it's not a long, but it's not committed relationship. We can choose specific machines, EC2, ECS, a lot of kind of resources, different databases, and it's kind of a car rental, I would say, / car leasing. And this is one of the great advantages because now I'm detaching all of the maintenance from my team. So if the team would look before like that, now it looks more like that. And this is me, I was in the dev. So, so basically, this is what our group looked like. Most of it, the majority of it, were developers. Not a lot of DevOps. By the way, the DevOps were more software oriented, less about like the maintenance and the switches and all of that. No, only about maintenance. And basically, this is how the organization looked like. And we were more invested in delivering features because we had suddenly the time to do it. Moving on. About 2 years ago, I joined LinearB, and this is where I met serverless for the first time. We heard a lot about it, but this is the first time that I was experienced with it. So when we think about our cars analogy, we're not talking about car leasing. We're taking it to the next step of car leasing, right? We are now paying only for what we are actually using. So this is kind of amazing because I don't need to pay for what I'm not using or what my customers are not using. And we have multiple providers to do it, and this is great. But how would my organization look? How my organization looks like now? So when I was working in cloud computing only by itself, the organization looked like this. But now in LinearB, when we are using most of our stack is serverless based, our org looks more like that. We have the majority of developers. It actually looks exactly like that. This is the number of the developers we have, and this is the number of the DevOps we have. And this is basically how our organization looks like. And we also managed to create developers that are independent, can do this multitask, and we are delivering much faster. Why is that? We all know what serverless provides us. It provides us flexibility. We can deploy really quick. We can get into real dev environments in no time. And this is super amazing. We can get to MVP really quickly, especially in the startup community. So we all know and we're all aware of what serverless advantages are, especially when it comes to specifically serverless framework. It's very easy to use. We are aware of it. But what about scalable development? So who of you works with serverless? Who develops in scale? Like, oh. Okay, you are working on serverless project? Not currently, but scale, I would point like the threshold, like more than 2 developers on one project. So this is what I consider a scale. So I'm going to talk a little bit about what happened to us, to our team, when we started to develop in scale over serverless projects. So what we did, or what we're doing in LinearB, we are integrating a lot of data, but from multiple providers. So we have a lot of data from our customers. This is specifically data from our organization. And what I did here is this calculation. I took our serverless projects. You cannot see it because, okay. And I did this calculation. On the blue line, we can see the number of releases, the ratio between releases and the number of contributors in my organization. Contributors is a single developer that contributes to the project. On the red bar, we can see the number of contributors. I would think that if I have a lot of developers, I would be able to release more. Make sense? Makes sense, right? I want to scale up. I want to get more developers. I want to deliver more. I would expect that I have more releases. So what we see here at the beginning of serverless project, what we can see here, that at the beginning we really don't have a lot of contributors. but the ratio between releases and contributor is very high, and it continues to grow. And once we are adding more contributors to the project, suddenly the release contributor ratio gets down. And this is something that a lot of data people would think, oh, maybe it's not only serverless project, maybe it's also some other projects. But we can see this trend very common for these projects, but not for other projects that we have in our organization. So this is very interesting thing to think about. But something happened here that made this a lot better, and we'll see what. So when we started to develop in scale, we got to a lot of issues. For example, we need to use or reuse our dev environment. So we have conflicts between developers that need to use the same one. So you can think about like, okay, you can deploy this function and this database and this Dynamo, and that's it. But sometimes you need the whole project to be tested in dev, and we only had one dev environment. And we were not able to, in a short time, to create another environment because the lack of the DevOps team that we don't have. So we had struggles in that area. Another struggle we had, this is like a typical, I would probably assume that all of you can solve it in no time, but when you work with scale and people that are not qualified to work with serverless get to common errors like serverless function exceeded maximum, we're all aware of it. But if you are not certificated, if you don't have the AWS certificate, you are not always able to understand these issues before. Also, we have the Lambdas timeouts that we meet all the time. So a lot of things that are related to the experience of serverless reached out to us very, very fast when we started to work in scale. More issues we recently got into is the 4 kilobyte limitation of environment variables. Another issue is the storage limitation of Lambdas. We got like into many issues. When we get this rollback not completed state, we don't know what to do. We get into an error and we cannot develop anymore. A lot of things like that. Also, about 2 months ago, AWS published this big article about their video services that they switched their architecture from serverless to monolith, and they were able to reduce their cost in 90%. So in terms of cost, we are not really qualified to understand our costs of our product as a developer, as the dev team. So it's something that we also need to take into consideration. So serverless. At the end, when it came to all of these stack of errors we got into, we got to a team that had a lot of context switch. We're not expert in this all ops area, and we were not that fast anymore for a small period of time. And we started to question, is it really a Superpill or just a skill killer? So no, this is not the end of serverless. This is not a skill killer. This is something that we only had to experience ourselves, to make our own mistakes and learn from it. And basically, this is not something that we are going to dismiss or leave anytime soon. Why is that? We are, from my experience, we are, not my experience, but specifically, I'm working on 2 products in LinearB. One of them is Gitstream and the other one is WorkerB. Both are event-driven products. So, sorry, the common thing about both of the products is that they are event-based and they are triggered by GitHub webhooks. And for that, I'm not going to take you into this whole architecture, but the product requirement really sits and fits well to the serverless architecture. So we're not going to dismiss those. And if we're going to see the architecture in high level, we can see it really fits well. So it's not our plan to dismiss serverless in any case. And we can see in the trend that I just showed you that by the time we got to a point that it really improved our release contributors ratio and made a major change. And what was that? So I'm going to separate our challenges into two groups. One is the tech part, and the other one is all of the resources part. So the tech part, we really got we overcome it by using new plugins that we learned about. And I'm going to share them with you at the end of this event. And the other one is to really get into our project the serverless programming practices. And the resource in the resource group, we established automated CI/CD for all of the new projects that we have right away, and this has really improved our releases contributors ratio. And we also created personal dev environments on a single account in AWS. This is the really cool things that we did, our team. So the next time that you are considering serverless, you need to prioritize high quality design to see it really fits to the requirements of the product. You need to understand well all of the use cases, and you need to take into consideration also the usage. And last but not least, developing in scale. This is something super important that we got into really fast when we scaled up in the amount of developers that we had in the team. So this is something that is highly recommended to take into consideration the next time that you are working on serverless framework. That's it.
Shalom. Did I say that right? I also know Nagila Hava, but I don't think that makes any sense. Right. Hi, I'm from AWS. I'm the Senior Developer Advocate for UK and Ireland. Brilliant talk. Thank you for that. I just wanted to talk about the article, since you mentioned the Prime Video article, because some of you, who has read that article? Yes, about the refactoring of the Prime Video. Yes, exactly. So I'm very aligned with the team. Oh, okay, yeah, sure. So I'll just talk very briefly about it, because of course there's been a lot of talk and a lot of misunderstanding about it, especially in the serverless community, saying what does that mean? So what it means is that it's important to note that this was a specific refactoring and optimization path that the team has done, right? And what does that mean in terms of serverless? So it's, who here is familiar with microservices? Yeah, most of you. So unfortunately, there was some bad wording that seemed like the refactoring was from microservices to monoliths and taking serverless out for cost optimization. Now, that's not the case. The Prime Video still runs on microservices, and microservices is full of serverless behind the scenes. So they have one microservice, so one thing that they call, and then behind the scenes, it called a bunch of other ones, and they consolidated that into a monolith, which runs on EC2, meaning they're not using serverless in that one microservice. That is a cost optimization path. And you can do that at any time. And we encourage you to do that as part of as our well-architected framework, to be constantly looking at options that will help you consolidate that cost. Serverless gives you cost optimization opportunities, but serverless itself will not save you money if it's not right for your workload. That's all it is. It's a different type of architecture. The metaphor that I like to apply is, imagine you have two kids, one goes to a school in the north, one goes to a school in the south. And then you think, okay, we're gonna have two cars, and one's gonna go to the south, one's gonna go to the north, right? Because you think gas is gonna be the biggest problem if you keep making that journey. Turns out that as you then look at your costs, you realize that the biggest cost factor is not that, is having two cars. Because the car, each one has insurance, each one has maintenance, each one has different things. And if you actually just did the one journey with one car, the gas price will be lower than the maintenance of the two cars. That's all it is. Serverless is absolutely still used in the Prime Video in most of the microservices they have. And this was just a way to show you an alternative. That's all. So absolutely agree with you. Serverless, not dead by any stretch of the imagination. And in fact, it is We have the serverless first mentality, which I call ASAP apps, as serverless as possible apps. It's my terminology. That just means you turn to serverless first and you refactor from that. And that's all that happened here. So that's all I wanted to clarify.
Are there any other questions? To Avishag. I just want to add to that, that one thing that I did take away from that article, which I thought was wonderful, was that it always was very transparent and authentic about their technology needs. They demonstrated how they can use one technology and also migrate to another, and be real about what their actual services require. And I found it to be a very, very interesting article. And we're all serverless enthusiasts, and we know it's awesome. And one of the things now we're going to hear, Avishag set the stage for the fact that, yeah, serverless is a really, really powerful tool for developers. So now we're going to bring up a developer who will tell you how quickly and with what Lego building blocks they built an incredibly interesting and powerful analytics platform, which just shows you how quickly you can ramp up really complex services today just with serverless resources. So we'll let Jonathan take that away. And one more time, I know that Linda came in a little bit late, so you're gonna have time to mingle with her after. She's gonna stick around a little bit, right? And also, I didn't catch your name, I apologize. And Mateus, who is here with us after the summit. It's gonna be fun. You guys can mingle with the AWS team, and it's gonna be great. So without further ado, let's add Jonathan to the stream. And welcome, Jonathan.
Thank you. This is a clicker, right? Oh, no, never mind. Okay, hello, everyone. So I'm Jonathan. I'm a full stack developer at JIT. and in this short talk, we'll show you an interesting use case that we had at JIT, where we had to work with a lot of data in a large scale. And just like David Melamed said before, we are only, like, all of our backend is in serverless. So we'll show you how we solved this workload issue using only serverless technologies, and how by knowing the correct technologies, you can save a lot of time and money and a lot of your own effort by letting Amazon do all the heavy lifting for you. Thank you, Amazon. So just like I said, we use AWS with a heavily support serverless solutions, mainly with Lambda, DynamoDB, and EventBridge, but also many others. And a very important part of that is our architecture is just like it says, mostly event-driven by using EventBridge. And I want to give a quick introduction to EventBridge to those who haven't had the chance to use it. Has anyone used it? Does anyone know it? Okay, so not many people. So EventBridge is a wonderful service in Amazon, and it's essentially a pub sub solution. So it's in many ways somehow similar to Kafka, but not exactly. Basically, what it does is it allows a single entity, like a Lambda function, but it can be any code that runs in Amazon, to publish an event. And this event, like I just forgot to say, like at JIT, just like you heard before, we help developers secure their platforms and their applications. And like in our case, an event in a system can be that a new security finding was created, or that a security finding has been fixed. And it's very possible that different moving parts in your microservices architecture will want to do something with this event, right? It can be many multiple moving parts that will have interest in a finding being created. So EventBridge allows you to do just that. It allows a single Lambda function to publish an event, and then it allows many different entities to subscribe to this event and do something with it. And basically, at some point, our product reached a certain level of maturity where we basically had to kill two birds with one stone. We wanted to take a lot of the different events that we had, because we're event-driven and we have many events being written in the system. And we wanted to show them as graphs, both in our platform for our users, so that we can show them how are they doing and how JIT is helping them. But we also wanted to send them to some third-party softwares like HubSpot or Mixpanel, if anyone heard of them. And so that our go-to-market teams can do some research there and use this data to find out how the product is being used. So basically, we wanted to take a bunch of JSONs from many different events and bring them to graphs like you see here, like those examples. And yeah, so like it said in the previous slide, we have thousands of events per minute. Sometimes it can be 10,000 in peak times. So a lot, quite a lot of events, and it's only growing as our user base grows. And our challenge was that we needed to subscribe to all of them, right? We needed to catch all of these events. We needed to then transform them to a unified structure. Like we wanted to work with a JSON in a similar format for all the metrics that we collect. So we wanted to transform them to a unified structure. We then have to send them to multiple destinations, right? We need to send them to our database so that we can then query it as part of the platform and show graphs like you saw before, and to send them to the third-party softwares that I mentioned so that our go-to-market teams can analyze them and do some research. And of course, we need to support a large scale. We assume that our user base is only growing and that the number of events will also only continue growing. So this is the solution. We're going to go over it part by part and show you how using only Amazon serverless options, we handled all of these events and we bring them to their destination with very little code of our own. And we let Amazon do all the heavy lifting and all the scaling, all the scale handling for us. So the first step, as you can see, like we have our services that put a lot of events in EventBridge. And the first step is EventBridge rules. EventBridge rules are an incredible service that basically allow you to subscribe to a specific EventBridge and then do some basic logic on it. And by basic logic, I really hope you'll be able to see it. I know this is small, but this is like a CloudFormation definition of an EventBridge rule. But what's important to see here is that we go over, these are the different fields that are seen in the specific event. And we then transform them to a unified structure that has a metric name, some info in metadata, and some info in data, because this is the way that we want to work with metrics. And what's incredible here is that it allows us to do this logic without any code, right? We don't set up a Lambda function. We don't have any EC2 instances. We only use Amazon-supported solutions. And we basically let them do all the scaling, and we don't have to handle any errors. And in this section, you can then set a target for this rule so that it knows to send this event to like a specific target. And in our case, this target is Amazon Kinesis, which we'll discuss right now. So Kinesis Firehose, that's the next part. Like right after the event goes through this transformation, it gets sent to Kinesis Firehose. This is another incredible service. And what it basically does is that it basically absorbs all of these events together. And once a specific threshold is passed, it can be like some time for like 60 seconds or a specific size, like 1 megabytes. Once a specific threshold is passed, it will group all of these events together. It allows you to run some basic logic on them using a Lambda function. We mostly use it to validate all the events and discard any invalid ones. And it then sends it to another destination, which in our case is S3 bucket, which we'll discuss in a minute. But what's important to understand here is that this is basically what allows us to make sure that when our code actually gets around to handling these events, right, because eventually we'll want to read them all in a loop and send them to their destination, because it has this 1 megabyte limit or any limit that we set for it, we'll know that our lambdas will only handle small batches of events with predictable sizes. And that means, like Avishag even showed an example in the previous talk, that you may suddenly encounter like a very large input and your lambda will crash. This is basically what allows you to prevent things like that, because now your lambda is always working with predictable sizes and of its input. And this is a very useful service. It scales as much as it needs to. If suddenly you have a lot of events, it will still keep these little chunks unified and in the same size. And it really saves us a lot of headaches. Basically, instead of writing a lot of code to do all this yourself, you just write a few lines in infrastructure as code, and you have it as a service. So once all of these events are absorbed and this threshold is passed, these events are sent to an S3 bucket. So who here works or worked with S3? It's one of the most common ones. S3, simple storage service. It's basically a service where you can dump basically all the files that you want and do whatever you want with them. And another really cool thing about it that you might have not heard about is that it allows, basically, when a new file is created there, it also sends an event that could then trigger a Lambda function. Basically, when a new file is created, in our case, it's a list of events, right? A list of events that we absorb from all around the system, from different services. We can then span up multiple Lambda functions that will have the file, that in their context, they'll have like a link to the file. And they can do any logic that they want on this file, right? They can pull it from the S3 bucket and do some logic on it. And what these lambdas do is we have two lambdas, one that sends the events to SemGrep, which is to Segment, sorry, which is a third-party software that that eventually sends it to HubSpot and Mixpanel, right? So that our researchers and product teams can do some research on it. And we have another lambda that sends it to an Amazon TimeStream database, which is a database that we use in our system, and that we can then query it and show graphs to our users as part of the platform. So once all of this has kicked in, but what we basically have is we have duplicate events so that both our market teams can research them on their own time, do some interesting graphs on them, and we can also show all of these events as part of our own platform to our users. And the last part I want to discuss is Amazon TimeStream. So TimeStream, which is the database that we send the metrics to, is also an incredible service. And so I just wanted to tell you about it because I personally didn't know it before we started working on it, and it blew my mind when I saw it. Basically, it's on the surface, it looks like a normal SQL language database, but it specializes in time-based queries. What do I mean by that? I mean that you can do queries like this. This is a normal SQL query, right, where you select anything you want. But then you can select, it has many built-in features that have to do with time, right? So if I want to show graphs for all the events that happened between like specific dates, or maybe from now until 90 days ago, you can query that with very intuitive and easy to understand keywords in the language. And needless to say, it's serverless, it handles very large scales, and for the most part, it works like magic. Of course, you have to understand, the bits and quirks, but overall, it works great like magic and saves us a lot of headaches. And now, because we have all of our metrics there, we can query them as we want. We can do joins between them. And basically, it allows us to do any graphs we want from all the events that we have in our system. And so just like you saw, the result is that we can show graphs like that to our users, and we didn't have to lift a finger, right? All we had to do was write very simple lambdas that get a list of events and do an API call to send them to their destination. So let's do a recap. We started from a lot of events, right? From different services. They have different structures. It's hard to work with them in their raw form. So we used event bridge rules to transfer them to a unified structure of JSON so that it's easier for us to work with them later. And we then send each event to Kinesis Firehose. Kinesis then absorbs all of these events, and it makes sure that when our code actually kicks in and starts working with them and processing them, it will only work with small batches with predictable sizes, so that we don't get like memory errors and our lambdas don't suddenly crash because we got a very large input all of a sudden. After Kinesis surpasses a specific threshold, it runs some basic logic on each lambda and sends them as a list, as a basic JSON list, just like you're used to an S3 bucket. And when a new file is created in this bucket, we can trigger as many lambdas as we want from that. All will have like access to this file. And each lambda will send these metrics to different targets. One of them will send it to our database, and one of them will send it to any third-party software that we want. And as you can see here, all of this can be set up with your infrastructure of code of choice with just a few lines. You don't have to write any code that has to deal with scale, right? This is the most important part here. Basically, Amazon deals with all of the scale, and we only have to write basic functions that deal with very limited data. And to me, like, this is mind-blowing. As someone who worked in on-prem before, I constantly had to think about large scale and unexpected events and, you know, all of these different edge cases. And now with just a few lines of infrastructure as code, the pain goes away and you don't have to think about it at all. And like, to me, that was just mind-blowing when I first saw it working. And yeah, I was just amazed by it. So that's it. Thank you all. And now I will now take any questions. Of course. Of course.
Do you have a magic integration between SQS and Slack, or there is a Lambda missing there?
Yeah, so there's a part that I didn't discuss. It's called dead letter queue. It's basically something that allows you to, like, if any Lambda fails for any reason, you can configure it to send the error to an SQS queue that will then send.
And that was my question. Does SQS send to Slack, or you have missing Lambda in between?
I think there's some configuration that you need to do. I don't think it's magic. We didn't draw this part in the architecture here, but I think it uses some internal service. I don't think it works like magic. But yeah.
Yeah, it's not magic. There is a Lambda in between that retrieves. Yeah.
Any other questions?
Any other questions? We got one. Woo!
Hey, thanks for the talk. So I was wondering about one thing about the event-driven nature of things. So one of the things that I found difficult when there's a lot of events is like two things. One of them being, you know, answering something like, hey, who consumes this event? Like, who actually uses this? And another one being just refactoring. If you have something like OpenAPI or gRPC or whatever, it's like more structured, but you know, firing JSONs everywhere is sort of difficult. So I was wondering if you had dealt with that and like, what are some of your thoughts?
Sure. So actually, I'll answer the second question first. The best way I can see for handling it is having objects in your code that represent these events. Like that's what happened in our code. We use Python with Pydantic everywhere. So all of our events are objects in the code. So they're much easier to work with, and you can always go to your source of truth. And regarding the first question, also, like, in my opinion, the best answer to this is to use infrastructure as code as much as possible. When you have infrastructure as code and everything is as files, you know, as code in your services, you can always see exactly which lambdas or which parts are subscribed to which events. You know, you can see it very clearly in the lambdas. Like, we specifically use serverless framework, and you can see it very clearly in the lambda what it wakes up to and what it listens to. So that is my answer to this. As much infrastructure as code as you can, and it solves this problem.
Cool, thanks.
Anyone else? Okay, thank you all.
Awesome. Linda, you're up next. We're doing them back to back, so nobody leaves. You're all stuck here until the very end. And then we can also make sure that everybody gets to mingle with the super awesome folks who showed up from AWS, despite being tired, despite being jet lagged, despite being all these things. They decided to spend one more night with our community. Yeah, the streamer. Exactly.
Okay. Right. Oh, my. Can you? Yes. So I didn't. We'll just go here. Okay. Perfect.
She's and whoever doesn't know, Linda has an alter ego, not really an alter ego, but she has a bunch of social media accounts you want to follow on TikTok, on Instagram, whatever your poison. Linda Viva, and she does these really fun DevOps type mini videos, musicals that you want to check out. And as a result, we are trying to convince her to come back to DevOps Days Tel Aviv to do the DevOps musical. So if you show her enough love, she will do that.
We're gonna have so much fun. First of all, thank you so much for all coming out. I'm so excited to be in Tel Aviv. אני מדברת עברית דווקא, וההורים שלי גדלו פה, ואני נולדתי בניו יורק, אבל ההורים ישראלים, אז we're gonna do some Hebrew, I guess. For the most part. Okay.
Share your
I'm
screen
entering the
also?
studio. Okay, I'm sharing my screen.
You share your screen or slides, whatever you prefer.
Perfect. Let me just make sure it's
If I can
sharing
just
my
add you to the
viewpoint.
stream.
I'm just going to do the entire screen. Hopefully it's not going to be
I probably could have done that. I'm an idiot.
this might cause inception. Okay, there we go. Can you see my screen?
Now we can see your screen. Awesome.
All right. So today we're going to talk about building and deploying a machine learning powered music genre classifier. This is Serverless Nights. So we're mainly going to focus on the serverless aspect of this. Before we get into what we'll be talking about a bit more, a bit about me, I'm a developer advocate at AWS. I'm here with my coworker, Mateus. Woo! I'm a former AWS community builder member. Do you know who knows what AWS community builders are? Awesome. Okay. It's actually a program you can apply to. You get a lot of perks. And if you use AWS or you want to learn more about AWS, you even get it's just a whole community of people learning AWS. Highly recommend it. So I was a community member for 2 years before joining. And yeah, I had an untraditional journey into tech. I was not a major in computer science. I ended up going to a coding boot camp, worked as a front-end engineer, full-stack engineer, then DevOps, SRE. And now I get to be a developer advocate and get to meet an amazing community. Was a wedding singer and all that fun stuff. Anyway, now to the more interesting stuff. All right, who here loves the music? Any music lovers? Favorite songs? Woo! Okay. So, do you know what this song is? Let's see if it's going to play. We're going to just try it. Ooh. Oh, no. Okay, let's try it. I don't know if it's going to play through the StreamYard. Oh, you know what? It would help if I would have this. Who knows? Hey! Okay. I don't know if you could hear it through the stream, but it's staying alive. Ooh. I hear myself. Oh, okay. Let me mute again. All right. So, more important question. Can you guess the genre? Anyone know the genre? What genre is it? Close? Could be. A little bit. Disco. Okay. Now, for a human, would you say it's super easy to guess a genre? Probably not. I don't know. And for a computer, probably even tougher. So how do we define genre? You know, it's not something that is that clear. So to train a machine learning model, even if, no matter what experience you have in tech, a machine learning model comes down to the data that's given. I'm not a machine learning, let's say, expert, but like the machine learning model and the training and how good it is comes down to the data. So there is a really cool data set called GTZAN. Have you heard of it? Anyone heard of it? Okay, this is actually one of the most popular music genre data sets. It's free, and it comes in audio and text. And you could use it to train and build machine learning models with it. Our main goal here, I'm not going to go super deep into any of the machine learning stuff, but our main goal is to get this data, train it, and then be able to also use serverless to deploy it and make cool applications, because that's what we want to do. We want to make cool stuff. Okay, so quick thing about this data set, I'll just give you the gist. It also, what's really great about it is it accounts for biases. So, right, you might have different vocal ranges. Jazz in the 40s might have, different kind of fidelity versus disco. So anything that has a lower fidelity might turn into jazz if you don't have it account for biases, right? So there's all these different things. And some of it is like hard to define or read, I don't know. But this specific data set comes in 10 genres. And again, going back to this question, how do we know that staying alive is disco? Well, you could look at the data, and there are a lot of different audio features. A lot of these I don't know how to pronounce. If any of you know, great. But a lot of these are things as far as the weight, and they could also be visually seen. So let's look just at a visual representation. Oh, before I get into that, there's something, I don't know if you could see here. It says Librosa. So all these audio features in a song, how do we extract them? There's actually a Python package called Librosa that could help you extract all these features that I couldn't pronounce that help you define what a genre is. And for the purposes of that, even if you're a machine learning engineer, right, you don't need to actually know all these, but this is the stuff that it has in there. And just to see a visual representation of this data, because it just makes it nicer, there's nice colors, you can see we took one track that's hip hop, one track that's classical, and you have these different sound waves. You can see kind of the differences, right? This is called a Mel spectrogram. It's like the weight of a song, if I recall correctly. And you could see the hip hop track versus the classical track. It kind of has these like, probably, I don't know, maybe a beat of sorts. I don't know. And again, this is another aspect. This is the 12 different kind of notes, right? And music, kind of see that. And here the bright color is also comparative to that. So I don't know, there's a whole science to this. But for the machine learning engineer, they get all of this like this in a CSV. Isn't that nice? And you can see the chroma, the spectral, everything we were kind of talking about. One day I'll know how to pronounce it. But this is what our data set will look like. So we have the CSV. And for the purposes, anytime I put my sunglasses, I'm just going to be the machine learning engineer. And if I don't have it on, it's the application engineer. All right? So for the purposes of this, actually, I probably won't be able to talk with that, but we'll go with it. So we have this CSV, this data. But how do we build and train it? So one of the services that you can use to build and train it is called Amazon SageMaker. Anybody have used it? Awesome. Okay. So it's a family of services. The main takeaway here is that you can build and train data in many different ways. One of them is using Jupyter notebooks. And you might be asking if you have used Jupyter notebooks. It's you could also locally run a Jupyter notebook. You don't need SageMaker, so why use SageMaker? And really because it has all these kernels already there. It has many algorithms already there. So we do have like the code for all that I'll share with you if you want to be building and training it. We have the code in this repo. For purposes of this meetup, we're going to focus also on deploying it. So let's say I had my machine learning model. Hold on. Had my machine learning model. Built and trained this model. Wonderful. Took the CSV data with all these words I did not read. And had a Jupyter notebook and put all that data into S3, the models.p file after like it exported from the Jupyter notebook. It uploaded this data to S3. Wonderful. It's an S3, right? How do we deploy it? Okay, let's see. So our goal, I'm the user or the DJ, and I want to deploy this to the cloud so I could make an inference and prediction from this song, right? I want to send a song, get the genre, right? We talked about building and training till now, right? This is what we want to kind of talk about right now. All right. So, yeah. So what tools do we use to deploy it? We could use servers. And of course, I'm in a serverless meetup. You might even ask what size, how many servers, how will the application handle? Pretty much a lot of questions if I'm going to use servers. And I don't know about you, but I want to focus on the business problem and not the operation and maintenance. So, hello, serverless. And this, of course, how many of you, I think many of you know what serverless is. But for anybody who doesn't, serverless does not equal no servers. It's an approach, an architectural approach, and it's an abstraction layer, and you only pay for what you use. I'm going to share an analogy I like, even though a lot of you probably know what serverless is, just because it's cool. So if you have a house and you want water, you might have a well, and you have to configure, have pipes and, all the different things that come into a well and start building it and drilling and all that. Or you could tap into the city water and just pay for what you use. That's serverless. It's just the CPU and memory. And now all of that, and now the networking, right? So, I don't know, so one of the most popular serverless services, which is a tongue twister, is AWS Lambda. And with AWS Lambda, you only worry about your code, right? You don't have to worry about everything around it. And it's event-driven, as we saw a few talks mention. And in our architecture right now, here's the most specific architecture of what we're going to do. We want to get our genre for our music. That's all we care about. We have our client, and they're going to send a request to API Gateway. An API Gateway is one of 200 services that can trigger a Lambda function. So that's going to be our main thing that we're going to use. And that Lambda function is going to get that information using Python and Docker from EFS. But didn't we mention that the ML engineer uploaded it to S3? What happened? Why do we need EFS? Well, we have an ML engineer, and he's uploading his model. She has a model, right? Uploading this to S3. Now the thing is, if I call this Lambda, right? If I am inferencing from S3, I would have to probably pay for every HTTP call, right? Because I would be calling directly, and I wouldn't have a differentiation. The ML engineer with the sunglasses, okay, wants to be able to change things, do things, and we don't want to call. We want a separation from the application developer who just wants to build a cool front-end application. Okay? So what we'll do is we'll have a Lambda function that every time this ML engineer uploads to a prod S3 bucket, it will trigger a Lambda function that will upload to EFS. And EFS is elastic file storage. It's serverless. Okay? And then it's able to then you just do the inferences from this instead of this. So who wants to see this in action? Should we try to code? Live code? I'm going to code with one hand. So the thing is, this is more like the storage system. He, she, whoever. Like we want to have a separation. We do want the separation, right? We don't want them to actually be in the same team. As far as the specifics of why not EFS, I would have to check if that's possible. I don't think that would be necessarily for this use case, but I will check. And so these are two different Lambda functions that you see here, right? And here's the thing. There were 5 to 6 services, right? Do we want to deploy these manually? Sure? Okay. I know who to call now. What service do you think we might use? Take a guess? Okay. Somebody said CloudFormation. Very close. Any other guesses? Okay, exactly. Infrastructure as code, right? So we're going to use serverless application model, SAM. Now, SAM, if you've used, right, Terraform, CloudFormation, right? It's infrastructure as code. Anybody use CloudFormation? Use Terraform? Okay, so we know, right? It's like, for anybody who doesn't, it's like an instruction manual. Instead of being like, I'm gonna make this Lambda and this API gateway and all this, I'm saying, here's the instruction. Read this top to bottom, spin it all up for me. Wonderful, right? We love a grocery list. So I'm kidding, it's not that, but you know. But so what's SAM, right? So if you've used CloudFormation, CloudFormation is infrastructure as code, and SAM is an extension of that, but for serverless. So what's the plus with this? What takes maybe 800 lines of code in CloudFormation takes 100 lines in SAM, right? So it's specifically for serverless. I don't know how much time I have left, but I would like to, if we have a minute, to spin it up and live code with you. Should we try? Woohoo! Okay, if you want, there's a QR code. If you want to see the whole project itself, we have all the instructions on there, including the ML training. So I'll give you just a moment to just screenshot that. And then we could do the thumbs up if we're good. Awesome. Woohoo. Okay. Let's see. So, this is for the end. All right. So we are going to go to Cloud9. You could use an IDE of choice. Let's see if it already has it loaded over here. I'm going to, might need to load it up. Okay. So we talked about all this architecture. You saw that whole diagram. That's what we want to deploy. But we want to deploy it with SAM, right? So I have a pre-deployed one right here. And we're going to look at the template, which is our SAM template. So, oops, no, I don't want to do that. You might be asking, how does it know if it's CloudFormation or SAM, right? Like, it's technically, you have to go to the CloudFormation service to see SAM, right? Well, see these 2 lines right here? I don't know if it's big enough. Let me know if it's not. But there is something that says AWS : serverless. That's how I know, because it reads it top to bottom. Okay? So that's what you know. That's how you know it's SAM, because it might look a little similar. And in SAM, you'll have 4 different sections. You'll have globals, parameters, resources, and outputs. And the quick gist is globals is anything you're reusing. For example, you're using a version of Python 3.8, you would put it in globals as a, and then you would reuse it throughout. Parameters is anything you define. Remember the machine learning engineer with the S3 bucket? S3 bucket names are usually global, so you need to be able, they're unique, so you need to be able to name it something, and maybe you want to input it, so parameter. And then you have a lot of resources. And the one I want to just take a look at before we start showing how to deploy SAM with SAM is this one. I'm coding with one hand. I'm very sorry. Very slow. Very slow. Let's actually search for function. This will be easier. Okay. So do you see this? Depends on mount target. So SAM is asynchronous, meaning when we wanted to get that the everything that was S3 to EFS, we need to tell it don't run this unless like EFS is there, right? So that's how you do it. You say depends on, right? So that's pretty much, because otherwise it's just going to run maybe without it being ready, right? So you see that's one of our functions right there, one of our Lambda functions, and then there's another one, and I'll go back to the architecture just so we have a quick look again. So here's the inference function. So those are our two Lambda functions, and then we also have our S3 bucket. Now the rest of the services are actually related to EFS because EFS needs a VPC and all these other things that you wouldn't need usually on the typical SAM template. But if you want to just take one look quickly, we just saw, these two Lambda functions. 1, 2, right? And it depends on EFS. All right, so now let's do it. So the first thing you do to initialize SAM, we're going to make a new one. This is my pre-talk one, just so because it takes a minute to. Sean, how much time do I have left? Oh, okay. Okay, let's just do this quickly. Let's see how fast I could do this, like holding it like this. Okay, SAM init. Oh, actually, first thing, we should probably check if we have our toolkit and all that. Oh my gosh, there we go. This is like perfect. Yeah. Oh, I know. I need bash. I need all the stuff. Oh my god. Okay. Usually when you want to initialize SAM, you would go SAM init. Oh my god. I'm not there. Hold on. It doesn't think I'm in bash. It's just okay. Did that fix it? There we go. Thank you. Team effort. Okay. The first thing I'm going to check, is there AWS installed? Yes. All right. Also, what else should I check? Anything else should I check? Let's see. I should probably check. Well, SAM is already, I think, here, right? Check SAM. Here we go. Check SAM. You see, I checked SAM. That's not good. SAM is not good. SAM. That's right. SAM version. Okay. We have our version 1.72. And the next thing we're going to do, SAM init. SAM init. And it's going to initialize. And you're going to see you have a choice. You can initialize with a GitHub file. So let's say the file that I shared with you before, you could actually use it, which is open for me right here. You could say, hey, let's pick number 2 and the choices. Let's go back to, I have too many tabs. Anyone have too many tabs? Too many tabs. Choice number 2, and I put the pat. I'll do .git. Okay. And I just kind of default all of that. All right. Oh, it downloaded it. Okay, re-downloaded it. Fine. Oh, you know what I forgot to do? I forgot to make a directory. Okay, live coding for you. Okay, let's make a directory. What are we calling it? Serverless Nights? The naming is the hardest thing. Don't you know? Okay, names. Serverless Nights. My name, Linda. Okay. Linda, yeah, Linda. Okay. Serverless. We're gonna be the ML powered music genre classifier. Okay. Serverless Nights. I can't write with one hand. Oh my goodness. Okay. Linda. All right. And now I'll just go, because of course I forgot to actually go into my folder, right? I was just like trying to deploy SAM into nothing. Okay. Okay. LS. We have nothing. Let's just clean it up. Okay. Now we will do SAM init. This is the beauty of live coding. Okay. Choice 2, and we're going to grab again our GitHub. We're going to go back here. We're going to do .git. Okay. So now does it understand where I'm going? Okay. Yes. Oh, I don't have it in there. Does it not understand? Oh, I made it inside the other one. I didn't go to my root. It's okay. It's okay. Fine. Okay. It just made a folder within a folder. That's not good. Anyway, but you see it all appears, right? It all appears in here. Here's your template. All right. The next thing you would usually do, okay, is you would SAM build, and you would use container. You need to kind of install all the local services. So SAM build, use container, I think. Hopefully I don't forget a dash. Kind of need to Google this half the time. Okay. Is it going to work? Yay. Okay. So like, And then it could kind of see the different options you have. So you could do SAM validate. You could validate your template right from the CLI. You don't need to go anywhere, right? It's nice. We like no tabs. I mean, I still have a lot of tabs, but it's okay. Validate. Okay, and then we're going to do SAM build. And that's going to take a minute. So I have a pre-built one, so we could go see that. Oh, the build failed. You know why it failed? Because I'm in a folder within another folder. That's why it failed. But if that's how it fails. So I don't want to take up too much of your time, but just move the folder outside to the root potentially. I did deploy this for the purpose of time to an API gateway. So it spun up the API gateway. Remember our architecture? Let's just take one more look, and I'll tell you where we're gonna go. We're gonna go test this. So we're deploying all of this with SAM. Okay, it usually takes a minute. It takes like 10 to 15 minutes, 10 minutes. I'm kidding. But this is where we're gonna go, Amazon API gateway. Okay. And we're going to go test if it understands my genre. So usually in the data set that we got, we used 80% of it to train, and we're using 20% of it to test. And then, of course, as you fine tune and do all that, I'm no ML engineer, but we start with that, and then we kind of fine tune further. So let's go to API gateway, which I will find in the next tab that I will go to. Let's see. We will go to the console. Let's just go to console, and I'll reload that. Hopefully, I didn't get logged out. Okay, we're good. API gateway. Thank you for bearing with me. Okay. Here we go. So this is one of it that it's spun up. And in here, there is a test functionality. You could test. And actually, if you look at this repo, there's actually instructions to build this yourself at home if you want to build some cool things. And I'm going to take this. This is one of the data sets here. We know it's blues because it's labeled out here, but we're going to see if the ML, if it actually outputs that. So we're going to test it in here. We're going to remove this comment. Oh, no. Okay, we don't look. This is okay. Here we go. We're going to test. Let's see. And it knew it was blues. But honestly, if we would have deployed it, and we didn't test one that I just pre-built, you know what we would be missing? Anyone know what step we didn't do? S3 bucket. We would have had to upload the S3 because the ML engineer wasn't in this picture. So the ML engineer would have uploaded the S3 bucket to the name that we gave to it in the SAM template. Okay. And if you want to learn more about and build with these kind of resources, I have a slide here with some resources for you that is right here. Okay. Oh no, wait. I'm always going to the end. Okay, not from start, play from current slide. I always do that. 1 second. And here we go. And there's a QR code as well. All right. Thank you so much. And Tel Aviv is the best. Such a pleasure being here. And Sharon, toda rabah.
Thank you. Let's give her a very special round of applause for going for the live demo. That's always a scary one. Any questions? We have two serverless heroes here, advocates. So we can also do an open mic and ask me anything. Eric is coaching me on how to hold the mic. I'm not doing a very good job, and I have noise. That's also because I'm a noisy person in general. But ask me anything questions. Feel free to ask them anything about serverless, not to put you on the spot or anything. Come on, make it hard, grill them. Anything? All right, thank you so much, Linda, for such an awesome talk. They're not going anywhere. Hang out with the community, meet them. There's more pizzas that were ordered so that you guys can have, and there's beers and drinks and stuff. And one more thing, first of all, big, huge thanks to LinearB for hosting. And in order for us to really know who came out, it would really be helpful if you just signed up on that sign-up form at the back. Just leave us your details, and also do join our community, WhatsApps, whatever, just so we can keep you informed. Thank you, Jonathan. Thank you, Avishag. Awesome. And thank you for spending your Thursday night with us. Stick around to hang out with Linda and Matthias. And we're out on the stream, FYI stream.